Good evening, everybody. Can you guys see my shared screen?
Yes,
Everybody else, do you guys see it? Can you hear me clearly?
yes, I can hear.
Okay. All right, so today's lesson is about decimals. Okay, so we spent the last few classes talking about fractions. So we learned a lot about fractions. Today we're going to see another form of numbers. So we talked about whole numbers in the beginning of the semester, then decimal, then fractions and integers. Now we're going to talk about some decimals. Another form of writing a fraction is actually a decimal. Um, so let's first define the parts of a decimal number. So a decimal number must have a decimal point. Okay, that's why the reason we call them decimals. There's some digits here, the decimal point, and the decimal part at the end. Let's say 8, for example, 8. 4, 1, maybe 6, or something like that. So this is the whole part of the number, and this is the decimal part. And each one of these place values has a specific name or a category. For example, here for the whole part, we all know that this is the first digit here is for the tens. Second one is for the hundreds.
Huh? Aren't that aren't those the tens?
Okay, the hundreds. Um, I'm sorry, actually I messed up. I messed up this part. The first one should be the
Tens, right?
That's what you were trying to say, right?
Yes.
Oh, I could barely hear you, but you're right. So it starts with the ones. This starts from the tenths. Okay, so this is the whole part. So we have the ones, the tens, and the hundreds. Okay, so that's the whole part. Okay, just like we learned so far. Then we have the thousands, 10,000s, 100,000s, millions, billions, trillions, and so on. But today we're more interested in the decimal part, to the right of the decimal point. So the very first digit here, what we call it, then we have another one, we have 1, and we have 6. So what we call this place value, where the 8 is. That's what we call, that's right, the tenths. Okay, not the tens. So the tens is the second place value of a whole number, but the tenths, the th, is the first place value in a decimal. What comes after the tenths? So we have 1/10 here.
Hundreds.
That's right, hundredths with a th also. Okay, hundreds, not the hundreds. This is the regular hundreds, but this is hundreds, or 1 out of 100. What about the next one? The next placement value is
Thousandths.
that's right, the thousands. And then the 10,000s and so on. 10,000s, just like this. The 100,000s, the million, then the millionth, as in 1 out of a million. But we'll mostly be talking about these 4 place values here. So tenths, hundredths, thousands, and 10,000s, and so on. So each one of those place values has a name, and that helps us identify the decimal components of a number, also to write the decimal in words. So for example, if you have another decimal like this, okay, so what decimal or what digit is in the, let's say, the 10ths position here? What digit is in the 10ths position?
The 4.
4, that's right. That's the 10ths. What about, let's say, the 10,000s? What digit is in the 10,000s position?
What? I'm sorry, Professor. Wouldn't the 7 be in the 10th?
Yeah, who said that? Yeah, you're right. Well, I said the 10th, so 7 is in 10th, that's right. And what digit is in the, like I said, the 10,000s position? 10,000s with a TH position. So we have tenths, hundredths.
The 1.
That's right, the 1. Tens, hundreds, thousands, 10,000s. Okay, 10,000s. Thousands like this. Okay, so and then what digit is in the, of course, the hundredths position? The hundredths would be, okay, that's the 4. And of course, the 3 is in the thousands. Thousands position, 10,000s, 100,000s, and so on. So you should be able to identify or label or name digit or a placement value in a decimal point. Okay, so now let's see how to basically write decimals in words. Based on this, based on these names or place values that we use to identify each digit or its location, we can write decimals in informal words, not just, for example, we say 0.1. That's not the formal way, just says 0.1. And read it in the formal way of decimals using the words so we just learned. So write in decimals. In words. So the very first decimal, probably, or the easiest one is this one here. So how do you read that decimal here? In addition to 0.1, what is the formal way to read it in this form here? We can say one what? One of what? What place value is 1 in if we base it on this?
1/10.
That's right. This is the tenths, and we have 1 here, so we say this is 1/10. We say 1/10, just 1, okay, without the S. This is the tenths position. We have 1 here, 1/10, which is basically 1 out of 10. That's the definition of a 1/10. 1 out of 10, as we saw with the fractions. If you want to, let's say, if we give you a whole piece of something like this, we want to shade 1 out of 10 or 1/10 of this piece. What do you do to get that? Recall what we discussed.
We take one pieces of 10.
That's right. So first we're going to divide this into 10 pieces. So this is
The 10 pieces.
That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got to be equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me go back a little bit. So approximately, let's assume these are equal. Still one more. Okay, so let's assume these are equal pieces. So we divide that into 10 equal pieces and you just take one out of them. So that's what 1/10 is. Let me erase this and do it again. It has to make more sense. Okay, so I'm going to try to approximately make these 10 equal pieces, 3, 4, 5. I believe that's 10. Okay, and then you take 1 out of that. So in terms of fractions, we discussed it before. We call this 1/10 or 1 out of 10. As a decimal, it's written like this, 0.1, and we read it as 1/10, just 1/10. If it's 3 or more, then we shade more. So that's 1/10. If you have, for example, 3, it would be 3/10. This time we add an S because we have more than one. It's plural, and so on. Same way. So this would be 3 out of 10. And you could also have 0.01. What is the formal way to write this in words? How do you read this decimal here, besides 0.01? If you want to read it in as something like this, what do you say?
100.
1/100th. That's right, 1. That's right, 1 and 100th.
100.
Like this. So you have 1 in 100 position. So we say 1. And you could have more than 100 here. You could have 1, 2, 3, 4, 7, 8, 9, 10, for example, up to maybe 17 or more. So this specific one, how do you read it again in the decimal form? You have 17 what?
1700.
That's right, 1700. So the highest one here is the hundreds. So 1700s, just like this. And maybe even something like this could be, let's say, 0.008. What would this be equal to? So this is 1 out of 100. This one here is 1 out of, or 17 out of 100. So 17. It's basically taking something, dividing it into 100 pieces, and you take 17 out of those. Here we took 1 out of 10. You can take any other pieces. What is this decimal? 8 what?
Thousand.
That's right, 8 thousandths. Again, thousands with th, not the regular thousands. The regular thousands would be here, but thousands, meaning 1 out of 1,000. And of course, what would this be as a fraction?
8
Over.
10,000. Yeah, over 1,000.
The way we read this, the way we read the decimal gives us an idea of what the fraction looks like. So 8 thousandths, 8 over 1,000, 100th, 1 out of 100, and so on. So you can easily turn decimals into some fractions or write them in words like these. What about this one here? So we have a whole part and then maybe something like this. Can someone read this for us in the formal decimal notation? So the whole part, always read it as is, 13 and something. So 13, the decimal we read as and. So 13 and what? What is this? It's kind of close to this.
13 and 2300ths.
Not hundreds, so we have the tenths, hundredths, and the thousands.
No, thousand, sorry.
right? So I'm going to say 13. And 23. Thousands. So when you write checks, you need to write the amount both in numbers like this and in words as well. That way, just to confirm that you meant the amount that you wrote on the check. And you can't say 0 point something. You have to write it, in formal words and phrases. And for example, if this was a check, this is not a valid part for cents. Usually you would have only 2 digits for cents. So 13 and some change, 13 and whatever handles here. So you want to write a check for this amount, 170 and 15. So we say 170 and 15 handles. Usually we write it like this, 15 handles. Okay, or you can write 15 handles. I believe you can write 15 handles on a check like that. So the cents will usually take 2 digits, the tenths and the hundreds. It's another way of writing the cent amount. So you say 170 and this in words. So basically you can write any amount or decimal in words the formal way. Now we're going to see how to turn. I'm going to see how to turn some decimals or some fractions actually. We go back and forth between decimals and fractions and mixed numbers. Just kind of like we did here. So 1/10 is 1 out of 10 and so on. You can also go back. We can turn also fractions into decimals. So let's say this decimal here. Okay, first, so we want to turn it into a fraction. So it helps, again, it helps when you read it in its formal way. How do you read this decimal again? (0.15), or if you want to write it or read it in this form, what is it? 25 hundredths. That's right, 25 hundredths. What would that be as a fraction?
25 over 100.
That's right, 25 over 100. Very simple. Just read it the way it's written. What about this one? Or just give me the fraction part of it. Or you can read it, it doesn't matter. You can read it in words, but I'm more interested in the fraction. So what is it here as a fraction?
123 over 1,000.
That's right, so 123 over 1,000. Basically, we get rid of the decimal. So we're gonna move it 3 times. It's like here, we kind of moved it twice to get rid of it. We put 2 zeros here, 1 and 2 zeros. If you move it 3 times, you're gonna say over 1,000. So 123 over 1,000, or you can say 123 thousandths. Okay, so you can easily turn fractions or decimals into fractions. You may also say, let's say you have this 5.4 or 5 and 4 tenths. What would this be as a fraction?
5/4.
As a fraction, 5/4.
I'm sorry.
500. 500.
It would be a five whole number and 4/5
So
or
it's,
4/10.
so it's already basically and 4/10. That's a good way to put it. So 5 and 4/10. So you can say 5 and 4/10. Okay, so 5, the whole part, and 4/10.
Professor,
Mm-hmm.
we cannot say 5,400.
That's also possible. 54, not hundreds. You can, if you move this once, it will be 54/10, or as a mixed number. So maybe mixed number makes more sense. So 5 and 4/10. So this is 4/10. So you say 5 is the whole part. The decimal part.
So if
Oh,
we
you
have,
just move the point one time. That's why it's 4/10.
That's right. If you move it one time, it means we're gonna put 1 0, just like you
Okay.
3 times and so on. So this is the improper fraction. This is the mixed number. So you can turn either into this or this. You can also reduce it. You can reduce them. At least this one, you can say 5. You reduce 2, you get 2/5. Okay, so 5 and 2/5. It's basically the same fraction. We just reduced it.
so is it if it's 5.6 is, let's say it's 5/6/10?
Do you want to turn it into a mixed number or a fraction? What's
A mixed number.
mixed number? So it would be 5 and what? 5 and
6/10, right?
6/10. That's right. 6/10.
Okay.
Or 5 and
6/10.
2/5. So basically,
Okay.
decimals are just another form, like I said, another form of writing fractions or mixed numbers. When we need precision, we need digits, we turn them into decimals. So there's always one whole part.
Excuse me. How do you get 5 over 3/5?
You said 5 and?
5, the last one you said equal to 5/3, right? That's what it says.
This one here?
Yes, yes.
3/5. Just reduce this. I reduced this by 2. 3/5. So 5 and 3/5 is the same as 5 and 6.
Oh, so you divide it. That's what I want to know.
That's right. I reduced it.
Okay, okay. Thank you.
So let's look at another one. Let's say you have, let's say, so let's turn this one. Let's turn this into a mixed number. So this is a decimal. So to turn this into a mixed number, what is it? 8 and what?
8
Mm-hmm.
100.
over 100.
Exactly. So 8 is this. And if you want to turn it into an improper, you can move this twice. Okay. So if you move this twice, will also be 8/1/100 because we moved twice. So you can either turn into a mixed number or a fraction. Whatever the question is asking you, you do the right method. So whole part.
Say that part again, Professor.
You can either turn this into a mixed number or an improper based on the question. Okay, so based on the question, you can turn it to either one of these.
And you change it by just moving the whole number? I'm lost.
The decimal, yeah, if you need. So this is a mixed number, this is an improper. They're both the same, all these three are the same number, just written in different forms.
Professor, if we do that way that you're doing, a 1/100, is we cannot simplify, just it's done.
If you can simplify, here nothing to simplify. Okay, but here, for example, I have 6/10. 10, we can reduce by 2. Always reduce your fractions. Reduce by 2, 5, or 3. It's still okay, but you may want to simplify it as well, like this. So you can go back.
And in the second way, a 1 over 100, we have to simplify.
If you can. Yes, it will. Most of the time, the question will ask you to turn it into a fraction and simplify. Speaking of simplifying, so this could simplify. I don't think there's anything that goes into both here. But for this one, we turn it into a fraction. Can we reduce it? Can we simplify it?
Yes.
Can simplify by 25. 25 goes into 25. Once.
4.
4 times. So 1 4.
4.
So the question will ask you to turn it into a fraction and reduce if possible.
Okay.
And reduce, you can leave it like that. But if it says turn it into a mixed number, then you do this. This is improper fraction. This is a mixed number.
So for the 801 over 100, you basically removing the decimal, or you have an arrow? What? Because you lost me completely there.
Yeah. So if you have, let's say 7.1, depending on what the question says. So this is a decimal. Let's turn this into a mixed number. If the question says turn it into a mixed number, so what is it?
7 and 1 10.
7 and 1 10. That's it. That's the mixed number. See if you can reduce this fraction. You can't reduce. What if you want to turn this into a fraction, an improper one? That's when you just move the decimal once. Here we moved it twice. Here we only have 1 digit, so it would just be as a fraction. 71 over, if you move this one once, it will be 10.
Oh, okay. I think I understand.
Same number, same. This is a mixed, this is improper. You can say also 10 goes into 71 7 times, and you have 1 left over 10. Decimal, mixed number, improper fraction. We can go back and forth actually as needed. Again, the question will tell you what to do. Question will ask you just one way, either do this to this or the other way. But we can go back and forth easily between decimals, mixed numbers, and fractions. And that's pretty much how you go back and forth between decimals, fractions, and mixed numbers. Now we're going to look at another thing, which is rounding decimals. Okay, rounding decimals would be number, oh, this should have been 3 here. So 1, 2, 3, and this is 4 now. So what do we mean by rounding decimals? You have, for example, some amount of money like this. You did some math about finding some amount of money from the price or something, for example, and you got this amount. But does this make sense in terms of cents?
No.
The cents usually have how many digits? With the decimal part of an amount of money. How many digits does it usually have?
2.
Just 2, that's right. It goes from 1 cent all the way to 99 cents. 1 cent here, all the way to 99 before it turns into $1. So if you did the math and you want to round this into something more meaningful in terms of money. So is this is 28 cents, and we have some number here. Is this closer to 29 cents or closer to 28 cents?
29.
29.
That's right. So it's closer. It's not about this 9. Could be any number more than, say, make it 7. Has nothing to do with this 9 here. So this number here is closer to 29 cents rather than 28. So you round this to the nearest cent or the nearest hundredths. So we have the tenths, hundredths. So to round this, you look at it, you say, oh, this is more than, it's 5 or more. If it's 5 or more, we can add 1 here. So this turns into 29, and you just ignore this number, okay? So we just round it to the nearest hundredths, to be specific, the nearest hundredths. So this is a more, so this is an amount that makes more sense. So you can give people change. You could give them 29 cents, for example, for change. But if you have 7 here, we don't have one thousandth of a dollar. We know that 1 cent is 1 out of 100. That's what 1 cent is. A dollar has 100 cents. But we don't have we have a coin for this, but we don't have a coin for 1,000th of a dollar. That does not exist. So we ignore this. If it's closer to, if the number is 5 or more, we round it to this cent here. If not, we just ignore it. So that's the concept of rounding. So we want to get rid of some numbers, but we want to get to the, round that number to the nearest place value. And the place value here is the hundredths, but usually the question will tell you what to do. Round to the nearest this or that. For example, let's do another one, nearest. So 8, let's say 8. So this number here, it's not an amount, it's not money, just some decimal. We want to round it to the nearest tenth. First, you want to find the place value of the tenths. So what digit is in the tenth place value?
4.
The 4. That's right. So to round to this place value, we'll look to the right. If this is 5 or more, we add 1 here. If it's less than 5, it's further than it's further down on the line if you look at it this way. So we have let's say 4 here and 5. This 4 here, we have 4 here and 5. This 3 is closer here to the 4. If you look at it this way, 4.1, 0.2, 0.3, 4.9 to 5. So 3 is closer to 4, 0.3 is closer to 4 than to 5. So to round this, so basically it won't change the 4. But if it was here, if it was 5 or more, this is half. This is basically 4.5. If it's 4.5 or more, then it's closer to the 5. We would turn this into 5. But if it's less than that, in this case, so it's closer to the 4. So we don't add 1 here. So in this case, it will be just 8.4, and just get rid of that number. So we just rounded this to the nearest tenth. Okay, so another one. Let's say maybe this time nearest 10,000ths. And I'll give you some number. So we have, for example, all these useless numbers. Okay, so we don't want to take all these. Sometimes we take 2 if we didn't with money, maybe just 1, depending on really what we calculate. Let's say for some reason we did some math, whatever, and it turned out to be like this. But we want to round our answer to the nearest 10,000. So first you're going to locate the 10,000th position. So which digit is in the 10,000th position?
4.
The 4, this one, right? Okay, let's see. So we have the tenths, the hundredths, the thousands, the 10,000ths. That's right. So we want to go up to here. This is the 10,000. Now we'll look to the right of it. Do we add 1 to this or not? We look to the right. Yes. Why?
Because the 9 is higher than 5.
That's right. If the number is 5 or more, for example, here, it's more or closer to the number here. If it's less than that, it's closer to this. Same thing with the 4 here. So 9 is much closer to the 4. So if it's 5 or more, so this is 5 or more, we're going to add 1 here and just ignore the other ones. So just cross all the other numbers. And this turns into 5.468, and this turns into 5. Okay, so the 4 here turned into 5 because we have a number here that's higher than 5, 5 or higher. And we just rounded this to the nearest 10,000. Again, make sure you can easily locate these place values, the tens, hundreds, thousand, 10,000, and so on. The highest probably we're gonna be dealing with is probably gonna be the 10,000s. But it works the same way for any other place value. Let's take this one here. So let's round this 3 times. Let's round this to the nearest 10th. What is this rounded to the nearest 10th?
$23.4.
That's right, nearest 10. So this is the tenths. We look to the right. It's less than 5, so we're not adding. It would be just 23.4. What about the nearest hundredths? Nearest hundredths?
23.42.
That's right, 23.42. So this is the hundredths. We look to its right. This is 5 or more, so we're going to add 1 here and ignore everything else after that. Everything else after the hundredths, just ignore it, turn it into zeros. It doesn't matter. So this is going to be 23.42. And finally, let's do the thousands. Okay, so this rounded to the thousand would be
23.418.
correct. So the nearest thousands, again, we have tens, hundreds, thousands. So we're looking at this one, and we'll look at the right, to the right of it. We have 8, which is 5 or more. So we're going to add 1 here. That's why we turned the 7 into 8. And that's basically how rounding works. Sometimes we have too many digits than needed, so we just need to take either 1, 2, or 3. So to the nearest 10th basically means take 1 digit. To the nearest hundredths, 2 digits. To the nearest thousands is 3 digits, and so on. If you need more digits and for some reason, you can always add zeros, because zeros don't change the number. Let's say you wanted to maybe add these 3 together. So you would add a 0 here for just to make all columns clear, and then you add. Okay, so it doesn't hurt if you add a 0 to the end of the decimal number, or to the front of it, in front of the decimal part. For example, when you say, I don't know, $25, and let's say 15 cents, it's still the same number if you add a 0 here, still $25. It's also still the same number if you put a bunch of zeros here. All that matters is this, so 15. These won't change the number, it's still the same. Let's see, I believe we kind of covered everything we needed. Let's double check, see we got everything. Yep, that's pretty much the whole thing for today about decimals. We still have other things to learn about decimals, including addition, subtraction, multiplication, division. maybe even the order of operations, but we'll leave those for another day. This should be enough for today. Did you guys have any questions about this before I give you some practice? Any questions of any of these parts?
No.
No questions, everybody? Okay. All right, give you some similar questions to work on here. Try to do those just like we did. So writing words, so one. Okay, right. Okay, so take these and write them as mixed numbers, fractions and mixed numbers both, basically. 2.5. Reduce if possible. Okay, reduce. Reduce when it is possible. Okay, so this one we're going to write in words. This we're going to write both in fractions and mixed numbers. That's improper fractions. And finally, round. So let's take this fraction here. So we're going to round to the nearest tenths, nearest tenth, nearest hundredth, also the nearest thousandths. Okay, so most of these shouldn't take you that long. If you understand what we're doing here, you could answer these. Most of these will take you literally seconds to do. Except for the fractions, it may take you a little time to reduce. Okay, so take a few minutes and I'll check with you when you're done. Okay, everybody, are you guys done?
Yes.
Everybody else ready?
Okay.
All right, so let's go over these together. What is the first one here? 1 and
7/10.
that's right, 1 and 7, rather in words, 7/10. What about this one? 3 what?
Hundredths.
That's right, 300ths. And here.
Teacher,
Yeah. What's up? Go ahead. Did you have a question? Did someone have a question, or should we go on? All right, 14 and what?
26 thousandths.
That's right. 6 and 26,000. All in words, 26,000s. All right, second one, write as a fractions and mixed numbers. So what is this as a mixed number and as a fraction? Let's start with mixed number first. 2 and
1/2.
2 and 1/2. You can say 2 and 5/10, right? 5/10, which if you reduce it, you get half. 2 and 1/2.
2, 1.5.
Okay. And as an improper fraction, if you move the decimal, it will be
25/10.
That's right. And you can reduce this at least by 5, right?
Uh-huh. And, 5 halves, 5/2.
Over 2. Very good. Here's another one. Start with the mixed number, or there's no mixed number here. It's a proper fraction, right? But we can turn it, because we don't have a number here, so we don't have a mixed number. But we can turn this into a fraction. What is the fraction?
75/100.
Very good. 75/100, which can reduce by 25, right? 25 into 75, how many times?
3/4.
3/4. That's right. And for this one, we can do both mixed and improper. Let's start with mixed number. 13 and
100ths.
400ths, which can be reduced by 4, so it will be 13 and
4/100.
4 25, right? If you divide by 4, you get 1. Divide by 4, you get 25. That's the mixed number. What about the fraction? If you move the decimal.
13
Mhm.
over
4
4. Uh-huh.
over
100.
100.
Exactly. Over
100, yeah.
twice. Very good. Finally, we have this one. There's no mixed number here because we don't have a whole part. But the fraction will be
17/1000.
That's right, 17 over 1,000. If you move this 3 times, you get 17 over 1,000. All right, now on to rounding. Nearest tenth. What is the nearest tenth? 28.
0.4.
You sure about that?
Oh, 0.5. No, I'm sorry. I was looking at the original number. Sorry.
That's right. So we look at the tenth. We look at 7. 7 is more. So this is closer to 5. So we're going to 28.5. What about the hundreds? This is the hundreds.
28.47.
That's right. We have hundreds here. 1 is way lower than 5. So we're going to just make it. We don't add 1 here. Finally, the thousands. This is in the thousands position. And are we adding 1 to this?
Yes.
That's right, 4, 7. And this turns into 2 and we ignore the 8. And that's basically your introduction to decimals.
Now, Professor, the 13.04, could it have also been
Reduce? Right.
13 1/10?
13 and 1/10. Well,
If you use the
why do you say that?
if you use 2 as the
If you reduce
no,
this,
it's 13 here, right there. If you use 2 as common denominator,
if you reduce 2, it will be 50. It will be 2 over 50.
right, and then
If you reduce again, it will be 1 over 20. This is the lowest one possible.
okay,
And this, you can at least reduce by 2, I believe, here. You can divide it by 50, and you can divide this, divide by 2, divide by 2. But this is the reduced part here. And that's basically, you can turn this into 67 over 50. And I believe that's the lowest you can get. Can't get any lower than that. Okay, that's basically how you do your decimals. And we will talk more on this subjects in the next couple of classes. But we're gonna base our, next few classes on this. And make sure you understand this. Review it before you do your homework. I'll post this lecture along with the homework for it sometime soon. Any